Yeah, okay. So from what we covered, like how you've reviewed our previous lesson, like I was telling you, chemistry, it switches this topic, this concept switches into this concept, and then this concept switches into this concept, okay, and so on and so on and so on. So all chemistry concepts must be part of you. You have no reason why you should forget. You have no right to forget any concept, okay. So that's why I had to first review the lesson. However, I was not recording, but I had to do it to see if the previous concepts, they are now part of it. So from that, now let's talk about the homologous series, and we shall start with the alkanes. And this is just simple work. This is just simple work. I'm sure in senior 3 you studied alkanes. Okay? You studied alkanes. And you found out that they are just saturated hydrocarbons. Okay? Saturated hydrocarbons with just a carbon-carbon single bond. Now, what does saturated mean? A saturated organic compound is that compound that does not have a double or triple bond. Once you have a double or triple bond, then you are referred to as unsaturated. But for alkanes, they are saturated organic compounds, or they are saturated hydrocarbons, okay, that do contain just a carbon-carbon single bond. And this is their functional group, okay. That carbon-carbon single bond is their functional group, okay. Yes, that's brilliant. That is brilliant. And with a general formula, they do have a general formula. Now the open chain hydrocarbons. Now what are the open chain hydrocarbons? The ones with just a straight chain, okay. The normal hydrocarbons, okay, they just have a straight chain. And all these ones, all straight chain hydrocarbons, they conform to this general formula of CnH2n plus 2, where n is the whole number and it's the number of carbon atoms within that organic compound. Am I communicating? Yes. For instance, if n is 3, then that one is going to be C3H8. Okay? C3H8. And if you have to draw its structure, it is just you write your C3. Okay? Now those are the 3 carbon atoms, and then you fill with hydrogens. Okay? So this one will take the 3 hydrogens, the same applies to this, and then this one will take, the concept is 1. Carbon has a maximum of 4 bonds. Okay? The concept is 1. Carbon has a maximum of 4 bonds. It doesn't go below 4, it doesn't go above 4, but 4 bonds. Okay? And this is an alkane. And from nomenclature, what is this? We are going to talk about nomenclature of alkanes. So this is propane. Okay, guess if carbon has, if your alkane has 6 carbon atoms and it is a normal alkane, it is going to be, yes, can you guess? Yes, it is C6. That's brilliant. H 6 2n, that is 12, plus 2, that is 14. Okay? Yes. And so when you are to draw, see this is how many? 1 2 3 4 5 6. So we shall put 3 hydrogens here. Another 3, 2 hydrogens, 2 hydrogens, 2, okay, 2, and finally 3. And this is going to be our n hexane. where N means normal hexane. Okay? Yes. If your N, if the number of carbon atoms maybe is 10, then this one becomes C10 H2N, which is H20, but plus 2, which is 22. Okay? And this is going to be your normal decane. And so on, and so on, and so on. So that's how these alkanes are named. That's how their structure looks like. And like I said, the functional group is a carbon single bond. And all the four valence electrons of carbon are involved within bonding. Then let's talk about nomenclature. And like I told you, we studied isomerism, but I was introducing you. And under each functional group, under each topic, and like I told you, the topics in organic chemistry, they are the functional groups. So under each topic, under each functional group, we shall study nomenclature of alkanes. We shall talk about isomerism. So it is just repeating. That's why whenever I'm teaching organic chemistry and I finish benzene, then I know that I'm just done. The rest is just repeating this previous work. So alkanes are named from the stem name. You add the suffix ane. Okay? From the stem name or the parent name, you add the suffix ane. Suffix is that, should I say, word or letters that do come at the end of the word. So you add a suffix ane. And where do you get the stem name from? The stem name is gotten from the number of carbon atoms. Okay? Whereby, if you have one carbon atom, then you are named as meth. Okay? Meth, this is, I think, Greek. I think it is Greek word. If not Greek, anyway, it's Greek word, which means one. Eth is Greek word, which means two. Prop, it means three. What does four? What is four? Four is beauty. That's brilliant. What is five? Five is, yes, that is paint. What is six? Six is, yes, hex. Good. What is seven? Seven is hept. That's brilliant. What is eight? Eight is, can you guess? Yes, eight is oct. Okay. Then what is nine? Can you guess? Yes, nine is sept. And finally, what is 10? What is 10? Yes, 10 is deck. Now, these are the stem names, or these are the parent names. And so in the parent name, we just add suffix ane. Whereby, if it has one carbon atom, and you add ane, then it becomes methane. If it has two carbon atoms, and you add ane, then it becomes ethane. If it has three and you add, it becomes propane. 5, and we add our ane, you can see, then it becomes pentane. 6, you add ane, hexane. 7, heptane. So basically it is as simple as that. There is nothing hard here. There is nothing hard here. Just add the suffix ane. Okay? And you get the name of the organic compound. Is that okay? Is that fair to everyone? Yes. So when it is branched, however, we studied nomenclature, but let's talk about when it is branched. For branched, you get the stem name, okay? And then you indicate the position of the branch. For a cyclic alkane, we studied all this in isomerism and we have videos, okay? You can always go and refer to them. So for cyclic alkanes, then the word cyclo is added, okay? But when it is branched and cyclic, then you name a branch and a position of the branch, and then you add the word cyclo. For example, let's see. Let's name, I think name, okay, since we have studied isomerism, you can always go and check our video. I can't write with yellow in yellow. So let's name this. You have this. You have this. And you have a branch here. A. Okay, you have a branch, and the branch is CH3. And then another branch here. CH3. Can you name this chap chap? Name that chap chap. Yes, we have studied isomerism and I know it's easy. Sorry, we have studied nomenclature and I know naming that one is easy. I can pause a bit. What? Which one?
2, 4.
Mm.
Dimethyl cyclopentene.
Okay. 2,4-dimethyl cyclo
Pentane.
Okay. That's a team. 2,4-dimethyl cyclopentane. Then Edwin. Edwin. Here. This is. So you are saying 2,4-dimethyl cyclopentane. Edwin, are you still there? Now from this, okay, I can say it was almost, but you made one mistake, and this mistake I cross. You see, the mistake is here. Why are you saying 2, 4? And which one is 2, which one is 4? So for you, you've considered this to be your carbon 1. No. Where the group is attached is the carbon 1. So if I take this to be the carbon 1, if I go this direction, then it will be on carbon 1 and carbon 4. But 1 plus 4, that's 5. If I take this direction, this will be carbon 1 and this one will be carbon 3. And 1 plus 3, that's 4. So we take the position, we take the side that gives us the lowest sum. And so we shall take this side. So instead of 2, 4, it will be 1 stroke 3, 1, 3 hyphen dimethyl. Okay? Dimethyl cyclopentane. So it is as simple as that. Okay? So, Otim, is it okay?
Yes.
So that is the small mistake that you made. Maybe we can name this one also. Let me first erase this. Let me use red. We can name this. Maybe. Let me not take things to be that simple. We can name this. This is, and then this. So you name this one chap chap. Let me not take things to be that simple. You got?
I got two methyl,
Let me write. 2 methyl.
2 methyl, 3 ethyl
A
butane.
moment, a moment. Let me charge. I'm going.